Welcome back to Statistics Made Simple. I am Savita Valsang, and in this video I'll be solving certain problems on operations research, that is basically the topics game theory and replacement theory, which may come as a 5-mark question in the second PUC board examination. In this video I am solving some important questions on game theory and replacement theory. In game theory, I'll be solving some problems using the maximin minimax principle and the dominance principle, which can come as a 5-mark question, and also be solving some problems on replacement theory, which again could be a 5-mark question. First problem, solve the following games using the maximin minimax principle. Is the game fair? The first question has player A with 3 strategies A1, A2, A3, and player B has strategies B1, B2 and B3. The payoffs are 3, 1, 2, 1, 0, 3 and 4, 2, 3. So this is called as the payoff matrix of player A. So the first step is to find out the row minimum. So here I'll form a column which is called as row minimum, and then you need a column which is called as column maximum. The row minimum value has to be circled. So in this first row the minimum value is 1. So circle it and write here. Then in the second row the minimum value is 0. So circle it and write 0 here. And in the third row the minimum payoff is 2 and write the value 2. Next, in the B1 column, you should find out the column maximum. So it is 4. Put a box or square around it and then write 4. The next maximum value is 2 in the B2 column. So put a box around it and write the value 2 here. And in the B3 column, the maximum value is 3. There are 2 3s. For both the 3s, you should put a box and write 3. Now, wherever you have the circle and the box is where the saddle point exists, and that is the value of the game. So now let us write the remaining steps below the matrix. So now first you consider the word maximin. Split the word maximin into 2 words, that is maximum of the minimum values. So this is equal to maximum. The minimum values are 1, 0 and 2, that is from here. And among these the maximum value is 2. So therefore we get maximin is equal to 2. Similarly, now consider the word minimax. So consider minimax, split it as minimum of the maximum values. So this is equal to minimum of the maximum values are 4, 2 and 3, and the minimum among these is 2. So therefore we get minimax is equal to 2. So therefore maximin is equal to minimax is equal to 2. Therefore the value of the game is 2. The best strategies for players A and B respectively are A3 and B2. That you have to see over here in the matrix. So this is where is the saddle point. The corresponding strategy for player A is A3 and for player B is B2. So the best strategies for both the players are A3 and B2. So is the game fair? Only if the value of the game is 0, the game is fair. You can write therefore the game is not fair. It's not fair because the value of the game is 2. Second problem, solve the following game using the maximin minimax principle. Is the game fair? So you have company X and company Y. They've given us the payoff matrix for company X, and company X has 4 strategies A, B, C, D, and company Y has 3 strategies P, Q, R. The remaining values you see here are the payoffs for company X. Now in the maximin minimax principle, we have to first find out the row minimum, which has to be circle, and then you find out the column maximum where you have to put a box. So let's form the column row minimum. So the least value is -1, so circle it and write. Similarly, in the next row, the minimum value is -1, so we write it here. In the third row, the minimum value is again -1. So write -1 and circle it. And in the fourth row, the minimum value is 0, and then we write 0 here. Next, you find out the column maximum. So in the first column, the maximum value is 3. So put a box and write 3. In the second column, the maximum value is 0. There are 2 zeros. So for both the zeros, you put the box, and next here you write 0. In the third column, the maximum value is 4, and then we write 4 here. Now we have to use the word maximin. I'll just change the color of the ink. So consider maximin. So split the word, which is equal to maximum of the minimum values, which is equal to maximum of -1, -1, -1 and 0, and a maximum among these is 0. So therefore we have maximin is equal to 0. Next, consider the word minimax. So minimax, split it. This is equal to minimum of the maximum, which is equal to minimum of the maximum values are 3, 0 and 4. The minimum among this is 0. So therefore minimax is equal to 0. So therefore maximin is equal to minimax is equal to 0. So therefore the value of the game is 0, and the best strategies for players A and B are, so see the payoff matrix here. So this is the saddle point and the value of the game is 0. So the best strategies for, let me make a small edit. It is for company X and Y. So for company X and company Y are D and Q. The value of the game is 0, so it is a fair game. Third question, solve the following game using the maximin minimax principle. Is the game fair? So you have player A with 3 strategies, A1, A2, A3, and player B has 4 strategies, B1, B2, B3 and B4. So now the first step is to find out the row minimum and circle it. So in the first row it is -3, the minimum value, and in the second row the minimum value is 3, and in the third row the minimum value is -2. So remember that among negative values, whichever is larger is actually smaller. So the minimum value is -2. Next, we find out the column maximum. So the maximum value in the first column is 4. So put a box around 4 and write 4. In the next column, the maximum value is 6. And in the third column, the maximum value is 3. So put a box around it and here write 3. And in the fourth column, the maximum value is 5. So write 5 here. So if you observe in the payoff matrix, wherever you have the circle and the square is the saddle point, and the value of the game for this problem is 3. So now let us write the steps. So by now all of you should be familiar. So we have to write consider maximin, which is equal to maximum of the minimum values. So this is equal to maximum of -3, 3 and -2. So if you observe, the maximum value here is 3. So maximin is equal to 3. Similarly, consider minimax, so which is equal to minimum of the maximum, which is equal to minimum of 4, 6, 3 and 5. The minimum here is 3. So therefore minimax is equal to 3. Therefore maximin is equal to minimax is equal to 3. Therefore the value of the game is 3, and the best strategies for players A and B respectively are A2, B3. Now they have asked us if the value of is the game fair. So since the value of the game is 3, the game is not fair. So you can write the game is not fair. So only if the value of the game is 0, the game will be fair. Fourth question, solve the following game using the dominance principle. Is the game fair? So in the dominance principle, for rows, we use greater than or equal to for the comparison, and for the columns, we use less than or equal to for the comparisons. So remember that horizontally means the rows and vertically means the columns, and among negative numbers, whichever is smaller is actually larger and vice versa. So now how do you work out the problem using the dominance principle? So first we compare the rows. So first compare A1 with A2 and then with A3 and A4. Then you compare A2 with A1, A2 with A3 and then with A4. Then A3 with A1, A2 and A4. And then A4 with A1, A2 and A3. If the rows don't work out, then you have to move to the columns. And the comparison is first you compare B1 with B2 and then B1 with B3. then B2 with B1, B2 with B3, and then you have to compare B3 with B1 and B2. So now let us start the problem. So first I'm going to compare A1 with A2. So it has to be greater than or equal to the payoffs. So 6 is not greater than 7. So A1 and A2 doesn't work out. Next do A1 with A3. 6 is greater than 5. 12 is greater than 8 and 7 is not greater than 10. Next compare A1 with A4. 6 is greater than 3. 12 is greater than 6 but 7 is not greater than 9. So next we move to A2. So compare A2 with A1. 7 is greater than 6 but 9 is not greater than 12. Next do A2 and A3. 7 is greater than 5. 9 is greater than 8 but 8 is not greater than 10. Then do A2 with A4. 7 is greater than 3. 9 is greater than 6 but 8 is not greater than 9. Now next do A3 with A1. 5 is not greater than 6. Next do A3 with A2. 5 is not greater than 7. Now do A3 with A4. 5 is greater than 3. 8 is greater than 6 and 10 is greater than 9. So we write A3 dominates A4. So you have to delete A4. So delete this entire row. So next, now we will move to the columns as all the row comparisons are done. Or we have compared A3 with the A4. So we have completed the rows. Now we'll move to the columns. So first compare B1 and B2. It has to be less than or equal to the payoffs. So 6 is less than 12, 7 is less than 9, 5 is less than 8. So you'll write B1 dominates B2, delete B2. Now next compare B1 with B3. 6 is less than 7, 7 is less than 8, 5 is less than 10. So you will write B1 dominates B3, delete B3. So let's delete B3. Now only the one column B1 is left. So you have to go back to the rows. And for rows we have to see greater than or equal to. So when I compare A1 with A2, 6 is not greater than 7. Next compare A1 with A3, 6 is greater than 5. So we'll write A1 dominates A3, delete A3. Now compare A2 with A1. 7 is greater than 6. So A2 dominates A1, delete A1. So now you have only one value remaining in the payoff matrix. So therefore, the value of the game is 7. The best strategies for players A and B are A2 and B1 respectively. Then you write the game is not fair. So only if the value of the game is 0, the game is fair. Fifth question, solve the following game using the dominance principle. Is the game fair? So player A has 4 strategies, A1, A2, A3 and A4, and player B has 3 strategies, B1, B2 and B3. So for the rows, when we make the comparison of the payoffs, it should be greater than or equal to, and for the columns, the payoffs, when we make the comparison, it can be less than or equal to. So now let us first compare A1 with A2. So 2 is equal to 2, minus 1 is equal to minus 1, but 3 is not greater than 5. Next, compare A1 with A3. 2 is greater than minus 1, but minus 1 is not greater than 0. Next, compare A1 with A4. 2 is equal to 2, but minus 1 is not greater than 0. Next, do A2 with A1. 2 is equal to 2, minus 1 is equal to minus 1, and 5 is greater than 3. So, you will write A2 dominates A1. So you delete A1. So next, compare A2 with A3. 2 is greater than minus 1, but minus 1 is not greater than 0. Next, A2 with A4. 2 is equal to 2, but minus 1 is not greater than 0. Now next, do A3 with A2. Minus 1 is not greater than 2. Then compare A3 with A4. Minus 1 is not greater than 2. Next, do A4 with A2. 2 is equal to 2. 0 is greater than minus 1, but 4 is not greater than 5. So next, compare A4 with A3. 2 is greater than minus 1. 0 is equal to 0 and 4 is greater than 0. So you'll write A4 dominates A3, delete A3. So let's delete A3. So now the row comparisons are done. Let us go to the columns. For columns, it should be less than or equal to. So I'll compare B1 with B2. 2 is not less than minus 1. Next, compare B1 and B3. 2 is less than 5 and 2 is less than 4. So B1 dominates B3, delete B3. So delete B3. So next, compare B2 with B1. So minus 1 is less than 2 and 0 is less than 2. So B2 dominates B1, delete B1. So next you have two rows, and for rows it should be greater than or equal to. So the two values are minus 1 and 0. So I'll compare A4 with A2. So 0 is greater than minus 1. So A4 dominates A2, delete A2. So therefore the value of the game is 0. The best strategies for players A and B respectively are A4 and B2. Therefore, the game is fair. It's fair because the value of the game is 0. Sixth question, solve the following game using the dominance principle. Is the game fair? So player A has 4 strategies, A1, A2, A3, A4, and player B has strategies B1, B2, B3, B4, and the various payoffs are given in this matrix. So remember that for the rows, we use greater than or equal to for comparing the payoffs, and for the columns, you can use less than or equal to. So let's start the problem. First, I'll compare A1 with A2. Minus 7 is not greater than 7. Next, do A1 with A3. Minus 7 is not greater than minus 2. Then A1 with A4. Minus 7 is not greater than 4. Next, do A2 with A1. 7 is greater than minus 7. But minus 2 is not greater than 0. Then A2 with A3. 7 is greater than minus 2. minus 2 is not greater than minus 1. Then A2 with A4, 7 is greater than 4, minus 2 is not greater than 2. Next do A3 with A1, minus 2 is greater than minus 7, minus 1 is not greater than 0. Next do A3 with A2, minus 2 is not greater than 7. Next A3 with A4, minus 2 is not greater than 4. Next compare A4 with A1, 4 is greater than minus 7, 2 is greater than 0, 3 is equal to 3 and 6 is greater than minus 5. So you'll write A4 dominates A1, delete A1. So delete the first row. Next is you have to compare A4 with A2. 4 is not greater than 7. Next do A4 with A3. 4 is greater than minus 2. 2 is greater than minus 1. 3 is greater than minus 2 and 6 is greater than 0. So now you have A4 dominates A3, delete A3. Next, we have finished the comparisons of the rows. So now we move to the columns. For columns, it should be less than or equal to. I'll compare B1 and B2. 7 is not less than minus 2. Then B1 with B3, 7 is not less than 0. And B1 with B4, 7 is not less than minus 4. Next do B2 with B1, minus 2 is less than 7. 2 is less than 4. So you'll write B2 dominates B1, delete B1. So delete the first column. Now compare B2 with B3. Minus 2 is less than 0. 2 is less than 3. So B2 dominates B3. Delete B3. So delete column B3. Next B2 with B4. Minus 2. You should check whether it is less than minus 4. It is not less than minus 4. Next do B4 with B2. Minus 4 is less than minus 2 but 6 is not less than 2. So next you have to go back to the rows again. So for rows it should be greater. So now I'll compare A4 with A2. So 2 is greater than minus 2. 6 is greater than minus 4. So you'll get A4 dominates A2, delete A2. So now delete A2. Now you just have one row remaining, so you have to compare the columns, and for columns the payoff should be less than or equal to. So now compare B2 with B4. So you see that 2 is less than 6. So B2 dominates B4, delete B4. So you delete B4. So the value which is remaining now is 2. So therefore, the value of the game is 2 and the best strategies for players A and B respectively are A4 and B2. The game is not fair. I'll now solve a couple of problems on replacement theory which can come as a 5-mark question. So the first question, the maintenance cost and the resale value per year of a machine whose purchase cost is rupees 7,000 is given below. When should the machine be replaced? So now in the question, first underline the word purchase cost. So the purchase cost you can underline, that is rupees 7,000. So now they have given the age in years, the corresponding maintenance costs are given and the resale values are given. So you need to know certain notations. You can refer to my main video on replacement theory where all the notations, many definitions are there and many problems are also solved. So this is just for last minute study. I'm working out a couple of problems on replacement theory. So age in years you mark it as N. The maintenance cost, it is denoted by CI. Resale value is also called as a scrap value. It is denoted by SN. So let us start the problem. So first you write what is given. So given capital P is equal to 7,000. So this is the purchase cost. Next we will write the formula. The annual average cost is AN is equal to P minus SN plus summation CI divided by N. So now the first step is to form the column P minus SN. So in the table form the column P minus SN. Actually these problems are very simple. There is only one formula which you have to learn and it is basically only calculations to get the final answer. So it is 7,000 minus 4,000. So you will get 3,000. Then next is 7,000 minus 2,000. 5,000. In a similar way, complete the other calculations. So you'll get 5,800, 6,400, 6,500, 6,600. Next, if you check the formula, you need summation CI. So summation CI means it is accumulated maintenance cost. So first write 900. Then 900 you add to 1200. So you will get 2100. Then 2100 plus 1600 is 3700. 3700 plus 2100 is 5800 plus 2800 is 8600. 8600 plus 3700, this is equal to 12,300. Now next, to find out the numerator, it is P minus SN plus summation CI. So to add these two columns, so 3,900, then 5,000 plus 2,100 is 7,100. Next you'll get 9,500, then 12,200, 15,100 and 18,900. Now the last column is AN, which is P minus SN plus summation CI by N. So take the value 3,900 divided by 1. So it is 3,900. Next 7,100 divided by 2 is 3,550. Next is 9,500 divided by 3. So is 3166.67. Then 12,200 divided by 4 is 3,050. Next 15,100 divided by 5 is 3,020 and 18,900 divided by 6 is 3,150. So now the question is, when should the machine be replaced? So look at the last column. So you should see, you will observe that the annual average cost is decreasing and it decreases to 3,020 and then immediately after that it increases. So mark this 3,020 with an asterisk and then circle the corresponding year, which is 5. So what should you do? In the last column you should see where the annual average cost is decreasing. So it decreases from 3,900 to 3,020, immediately after which it increases. So the point where the annual average cost decreases and then increases, that would be the period in which the machine should be replaced. So now write the last part, that is the conclusion. The machine should be replaced at the end of the 5th year. You should use the word at the end. So, okay, at the end of the 5th year, and the minimum annual average cost is rupees 3,020. Second question, the cost of an equipment is rupees 61,000 and its scrap value is 1,000. The maintenance cost from past experience are as follows. At what year is the replacement due? So they have given us the years from 1 to 8 and the maintenance costs are given. So now let us start the problem. Let us write the values which are given to us in the question. So start the problem, write given. So they have said the cost of an equipment is rupees 61,000, means the purchase cost, that is capital P, is 61,000. So the scrap value has another term which we used in a previous problem, that is the resale value. It is denoted by SN and it is equal to 1,000. Next, write the formula, the annual average cost is AN is equal to P minus SN plus summation CI divided by N. So also note that P minus SN is called as a depreciation cost. It may be helpful in some objective type of question. So now the year you mark it as N, the maintenance cost you mark it as CI. Next, what we have to do is we need to find out P minus SN. So let me find out P minus SN. It is 61,000 minus 1,000. So it will be 60,000. So now in the table, I'll form the column P minus SN and throughout I will write 60,000. Next, we need summation CI. So form the column summation CI, that is the cumulative maintenance cost. So first you have to write 1,000, then 1,000 plus 2,500 is 3,500. So next is 3,500 plus 4,000. So 7,500. Then 7,500 plus 6,000 is 13,500. Then you will get 22,500, 34,500, then 50,500 and 70,500. Next, you have to form the column P minus SN plus summation CI. So add these two columns. So you'll get 61,000, then 63,500, 67,500, 73,500, 82,500, 94,500, 1,10,500, and then 1,30,500. The last column is AN. So 61,000 divided by 1 is 61,000. Then 63,500 divided by 2 is 31,750. Next you will get 22,500, 18,375, 16,500, 15,750, then 15,785.7, and the last value is 16,312.5. So now in the last column you should see how the costs are decreasing and the point where it increases immediately. So if you observe carefully, the first cost is 61,000. It is decreasing to here 15,750, and then immediately after that it is becoming 15,785. So mark 15,750 and the corresponding year you have to mark, which is 6, and so you can write the conclusion. The equipment should be replaced at the end of the 6th year, and the minimum annual average cost is rupees 15,750. Thank you all for watching my channel Statistics Made Simple. I really do hope that all the videos which I have posted, especially the 3 model papers for the 2nd PUC examination and some of the important and sure questions on the chapters, index numbers, vital statistics, interpolation and extrapolation, the normal distribution, and now on game theory and replacement theory. I really hope that these sure questions and important questions are useful to many of you. I wish you the very best for your examinations, and I'm confident with a lot of practice that most of you will score exceptionally good marks. Thank you.